Hello everybody. Welcome to our presentation called Do You Think You're Doing Microservices? That's actually related not only to microservices as such, but pretty much about their infrastructure that is needed to do microservices. But before we go to the very topic, we'd like to say a few words about ourselves.
So my name is Lukasz Szczesny. I work as system engineer for Finance IT. I'm co-organizer of the Warsaw Linux user group and a big fan of automation and DevOps culture. You can find me on Twitter, and there is a link to my homepage at blog, but it's not visible at all, I think.
And my name is Marcin Grzejszczak. I'm a software architect for Finance IT, where we are doing microservices on a daily basis. I love testing. That's why I wrote 2 books about Mockito, Mockito Instant and Mockito Cookbook. I love Groovy. That's why I am a co-founder of Warsaw Groovy User Group, and I committed a AST transformation called Builder to the Groovy core. And I really love microservices. That's why I am a co-author of the For Finance IT micro-infra Spring libraries that allow you to actually use microservices in a very cool way. My Twitter handle is mgrzejszczak. My blog is toomuchcodingblogspot.com. And that's pretty much it. So what's the agenda for today's meeting? So we'll start with a very short introduction to microservices, and then we'll move smoothly to how to actually deploy a microservice to production. So we're going to go through all the stages of writing code, testing it, etc. And then we're going to say a few words about the problems that can occur while doing microservices. So let's start with a short introduction to microservices. Who knows what microservices are, actually? Please raise your hand. So, okay, like 10 people out of the whole room. I don't believe that. Everybody's doing microservices these days, right? So if you have ever been to a talk about microservices, you have for sure heard about Conways law. So let's start with theory. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Awesome, but what does it actually mean? It's like pure theory. But it's actually not really theory, and I'm going to give you an example that we had in our company at For Finance. So imagine such a case that we had a team. There were 4 developers working on a single code base. They were supposed to do one feature. And 2 of those guys were in Poland, and 2 of those guys were in Riga. And everything was awesome, everybody was happy, until they started to do pull request reviews, okay? So the Polish guys did reviews for the guys from Riga, and the other way around. What happened was that they weren't happy with the comments. So actually they stopped doing reviews like country to country, but they started to do the reviews in pairs. So Polish guys did the reviews for themselves, and the Latvian guys for themselves. So what happened because of that? Actually, the concept was such that we have one team in 2 countries working on a single code base, right? But what happened in reality was that we had 2 teams, not one. It was working in 2 countries on one code base. And what happened, what was the effect of the work was that they created 2 different solutions solving the same stuff in one code base. Because the organization looked like this, right? This was not one team, but 2 separate teams. That's why they created exactly 2 different implementations doing the same stuff. So what goes behind Conway's law is that if you do siloed teams, like you have UI guys, you have DB guys, middleware guys, you're gonna create, most likely so, the architecture that will look alike. So what we favor, and we were trying to do this for finance, is to do cross-functional teams. So team should be responsible for a product, for a domain. And inside this team, we should have DevOps, we should have developers, QAs. All of them should create like a team responsible for a single stuff. It's not really easy to do that because of some management issues, but we're trying to go that way. Why should we do it like this? Because in the reality, when you have a business flow, for example, a guy wants to take a loan. So he goes to some front office, says, I want a loan. And people from the front office, let's say, go with some paper that the guy wants a loan to the back office. And in the back office, they insert some data, and they tell the guys from the accounting that the guy wants the money. This is like the real business flow. Whereas, imagine that you have a monolith application, a big one, with many programmers in a big organization where, let's say, the packaging wasn't the best from the very beginning. And we have to have such cool packages, right? DTO, service, and my favorite, impl, and entity, right? It's like normal, everybody has it. So let's say that we want to create a new feature for accounting, so we have to do it in 4 places, right? And let's say that we want to add some back office stuff and front office stuff, right? So it has to be added in all of those places because we want to develop a feature. So when we try to make it all talk together, we might end up with something like this. So it does remind us with spaghetti code. And that's actually very common these days, that the code looks like this. So what should be done actually in terms of microservices, that you want, let's say, to create some processes that will take care of a bounded context. For example, related to front office. And it should be autonomous, so you can deploy it, version it separately. Those processes should communicate with lightweight mechanisms like REST, for instance. Those bounded contexts should be business-oriented, not technically, or let's say, oriented over technical stuff. Sometimes it does make sense, but in general, it should be business-oriented. And if you need special, let's say, versions of libraries, special languages, special databases, microservices allow you to do so because you can be polyglot. So one last thing related to like some theory and discussions that take place in some forums or whatever. People tend to talk about, I mean, we don't want to use microservices. We prefer service-oriented architecture. But what is SOA, in fact? It's a very broad topic, right? But typically it's understood as XML and SOAP, and we have some WSDL over there, definitely. And ESB for sure, right? This is what typically people understand. But actually, what microservices are is like more thoroughly described service-oriented architecture. So it gives you better boundaries. So that was a very short introduction to microservices because, I mean, we could talk about this for hours. But since the majority of you, I guess, knows microservices, let's focus on the most important stuff, so the infrastructure challenges. So we would like to deploy a microservice to production. So let's go step by step. So the first thing, let's write some code. So as a developer, I want my microservice code base to be small, right? That's the idea. If I am supposed to write a microservice that has 10,000 lines of code in each class, then okay, we changed the name, right? It's not a microservice. I want it to be small. Because if it's small, I can support it properly because I can understand what's going on there. And actually, I want to be fully responsible for that microservice from the very beginning until the end, from the first line of code until it goes to production. Also, I don't want people from outside of my team to do changes to my code base without my approval. So, because we have some standards that we define in a team, and I don't want people to break those standards. Lukasz, how can we solve this?
So first you have to introduce code review or working via pull request. In our company we are working via pull request, and this is a very, very cool way of working. Nobody messes with others' code. As well as the dev team should be fully responsible for continuous delivery pipeline. If pipeline is broken, pipeline is red, the team should stop doing whatever the team does at the moment, and fix the pipeline, fix the issue with pipeline. And the last thing, the dev team should receive all the alerts from monitoring software and from Pingdom and et cetera. So the next step is...
So let's say that we wrote the code. It's done, it's reviewed. So let's build it. I mean, it happens in the meantime, but let's focus on such sequence of things happening. So let's build it. So as a developer, in fact, I'd like all the services to be built alike, right? So imagine a case where you have 100 microservices, and each of them is built with a different tool, in a different way, with some different standards. I don't want such a situation. I want standards to be there. I want one way of building the app, because it's easier to comprehend and support the application afterwards. Also, when I'm building the code, I want to have immediate, as fast as possible, the feedback if my code works. So, Lukasz, again, let's solve this.
The answer is simple. We have to automate all the things from the beginning. So, starting with our continuous integration, continuous delivery, we coined a phrase Jenkins as a code in our company. We are moving towards Jenkins as a code, that we are creating all the jobs, all the templates programmatically. We are also deploying Jenkins master and slaves automatically using some kind of configuration management code. As well, as I said, Jenkins job creation should be also automated. Nobody should touch the UI of Jenkins. We don't want developers to log into Jenkins and change configuration on the fly, because we have always issue with this. Somebody remove the job, change the Gradle script, and everything is broken. And also, we should introduce one pipeline for all the microservices, one pipeline template, and deploy all the microservices in the similar way. So we are able to introduce new microservices very quickly in our environment. Okay, so next slide. On this next slide, as I mentioned, Jenkins as a code. There's a plugin for Jenkins called Jenkins Job DSL. This is a sample code for this. So this piece of code creates jobs for each branch for specified GitHub project. So this is very easy way for creating new jobs and new templates. Not templates in common sense, but templates in code, in Groovy code. Just you are programming in Groovy and creating new jobs and new templates and stuff in Jenkins.
Who has seen this Jenkins Job DSL or is using it in their companies? One person. Oh. So if you have anything like say to take back from this conference or from our talk, this has to be one of the things, because once you touch this, I mean, there's no going back, because why on earth should you click a job in Jenkins if it can be generated for you? Together with Lukasz, we're organizing microservice hackathons. If you want one to be organized in your city, just call us. Over there, we create an organization on GitHub. We have 14, let's say, services to be built. And we have one code that accesses the organization, creates 14 deployment pipelines, creates the views, creates everything for us. We basically do nothing at all. I mean, you can get fired for that. But in general, it's the way you should go, full automation. You shouldn't be clicking anything.
And also, this is superior, because you have this Jenkins jobs are versioned and are auditable. So you know who changed what and when and why.
Okay, so we wrote the code, we build it, now let's test it. So, as a developer, when I'm coding, I don't want to hard code any services, IPs, and ports. Why should I? I mean, people talk around, when they're talking about microservices, they talk about scaling them. So, if I hard code a IP and port, how on earth can I shoot to another instance, right? It's impossible. Or I can shoot to some load balancer, but it's getting more difficult.
We have a question there.
Yeah, that was exactly what you could do.
Yeah, so I'm faster than you think. So, sorry. So, also, when I'm doing the tests, I don't want to set up the whole environment. Imagine that you have 100 microservices, and you want to run the tests. I don't know how big machine do you have to perform the end-to-end tests over there with running a request, passing through 100 services. Good luck. So I'd like to test my application in isolation. You heard about TDD and stubbing, right? So you can do the same on an architectural level. Also, I'd like to ensure that others can reach me, and if they send me a request, I will be able to parse the request. I have to be sure of that. If it's not positive, then let's say the whole foundation of this testing goes down. So the fundamental thing is that if I publish some contract of my service, I have to be telling the truth.
So for sure, we can manage. So we can solve this problem of hard coding IPs and ports in the configuration or even in code by using service discovery. So we can find easily our collaborators by name and get the port and IP address or something else from this service discovery. So we can use Zookeeper. We are using this in our company. We also use this in micro-infra Spring library. As well, you can use Consul, Eureka, etcd, and many other solutions are available on the market. So you have a lot of stuff to choose from.
Who of you is using Spring Cloud? On production, anything? One person. Who heard about Spring Cloud? Okay, some more. So in Spring Cloud, there is no, I mean, there is a POC related to Zookeeper, but actually our company is doing pull requests to Spring Cloud to, let's say, make Zookeeper be also possible as a service discovery tool. So go ahead to the Pivotal's GitHub and you can see the progress. Hopefully, in some months we'll finish that. But for now, if you're using Spring Cloud, I think you can use, I mean, for sure you can use Rika. And I think you can use Console, but the rest is not there anymore, and they're planning to add it in the future. So, has anybody heard about consumer-driven contracts? Okay, a few people. Do you know the ThoughtWorks technology radar? There is such a thing that they publish. One of the things that they actually published was that you should adopt consumer-driven contracts. And what is it actually? Before we go to the very the definition or like showing the implementation, imagine such a case that you have two services, one in version 1, one in version 2. So that's it, that's your whole world that you have. So how can you test that? Let's do end-to-end tests, why not? I mean, you're gonna have bigger, let's say, chances that the thing works. You're gonna send a request to the first jar, it's gonna send a request to the second one and go back. There's like no rocket science over there. But imagine such a scenario, right? If you have 6 services and very difficult, let's say, workflow of requests, it's passing around, synchronous, asynchronous, everything, right? In different versions. So for sure, when your test goes down, when you see it on Jenkins or any other tool, it could have been because you deployed like the top right service in version 8 and it should be version 9, right? It's not possible, right? Of course it is. So now you have to maintain 2 things. The big environment, the versions, and check when something goes down, when it does go down, you have to check out exactly where it came from, the issue. So it's being very problematic. So you don't always have to write to end-to-end tests. You can test in isolation. It's not easy, but it's possible. And this is where consumer-driven contracts can come and help you. There can be a mean to, let's say, minimize the amount of end-to-end tests, but they can give you more benefit that your applications will talk to each other. How is it possible? Let's focus on the one to the top left corner, in the top left corner. So you don't have to actually talk to the real guys. You can talk to their stubs. So instead of having a big environment, you can have a smaller one and test the application in isolation. But it's only feasible when the stub, so this puppet that I showed you, is tested against the server itself. So if I'm a server, Lukasz is a consumer, and he's shooting me with a request. If I tell him that, hey, if you shoot me at request /a with a get method, I will return you foo, like a body. If I say so, it has to be the truth. So we have to test my stub against my own implementation. Only then can we tell that it makes sense, consumer-driven contracts make sense. So once I tested my stub against myself, can I publish the stub somewhere in Nexus or something? And then my consumers, like Lukasz, can download the stub during their test and run the tests against my stub because it's valid, it's been tested. And that's why on production, the probability that you send a request and the other part says, I don't know what this is, right? I cannot parse it. It goes down really to minimum. So let's say that we tested it. So now we'd like to deploy it somewhere, right? So as a developer, I'd like my feature to be on production as soon as possible, right? Because I want to have immediate feedback. I don't want people to tell me if the application is working properly, and I want to see the results of my job. Also, I'd like to have application configuration in one place that is auditable and secure. How many times did you have a problem on production that you had to, but of course one last time, SSH to production with a VI afterwards to change the properties of your applications? Of course, one last time, definitely. I mean, everybody was there, been there, done that, right? But it's not the way to go, because afterwards somebody else, edits the same file or forgets to make another edit on a second server. So this is not the way you can go in a microservice environment. So how can we deal with that, Lukasz?
So again, we have to automate all the things from the beginning to the end. And starting with environment provisioning. We should provision all our environments automatically. Maybe we should also go into infrastructure as a code. So we can use some kind of tools which we name here: Puppet, Chef, Salt, Ansible, and many more. Everything which suits your needs is okay, but you have to keep environment provisioned, keep environment versioned, and it's the key for multiple. If you want to scale, and if you want to deploy from scratch, it's the key for successful deployment. As well, this application deployment. How many of you use SCP for deployment application? You're SCPing some jar or tar.gz to the server, and nobody? Wow.
Who is pushing classes to the jars? Nobody. That's
Nobody.
good.
That's good. So we use Rundeck for application deployment. Also, we can use Capistrano, Fabric, Ansible, and Freight. It's a new tool worth noticing. So you can Google it. It's a very cool tool. And there are many other tools which can help you with deployment, with auditable deployments and secure deployments. So next thing, which Marcin mentioned, is application configuration. So we would like to have configuration on servers in secure way and versioned. We should version the configuration. This is the first thing. As well, we should encrypt some secrets which are crucial for our application. For example, passwords for external providers, password to the database, and so on and so on. Okay, so how to do it? If you are using JVM-based applications, you can use Spring Cloud Config Server for property storage. Or you can use microintra Spring Config, which is a little bit superior to Spring Cloud Config Server because we enable you to use some kind of tree structure of configuration files. So you can have one configuration file for whole environment, one configuration file for specific country and for specific application. So what's next? It's monitoring.
Yeah, let's say that we deploy the application to production. Is it the end? It's actually not. But why is it so? Because as a developer, I'd like to, not have to grep my logs from different servers. Who is grepping the logs to see the errors? Who is happy with that? One person. Congratulations. You have to see, Kibana, so you're not going to say the same thing again. So, searching for errors with tail and grep, okay, you can do that. You can do everything, but why should you? So imagine the case where you're scaling. You have someone said that there's a bug on production, that something broke, and you have a service that's deployed to 6 servers. Where are you going to SSH? To which one? Which instance had the exception? You have to download all the 6 logs and do merge it somehow. Terrible stuff. So we can do it in another way. Actually, it's not only related to the logs. Actually, I would like to have in one place the logs, metrics, and health status of my applications. So how to do that?
So regarding logs, we have first thing which we did on our production, and you should do as well. It's unify logging patterns, because we've seen some patterns, and those patterns were bad, and we are dreaming about those patterns. And
these are nightmares. Have you ever thought of putting your email that whenever an error is sent, I mean, there's an error, some particular guy should receive a mail with an error, and there was a username and password provided there to the email. Come on.
So you should collect logs in one place. If you're a traditional one sysadmin, you can use syslog. If you wanna go hipster mode, you can use Elasticsearch log/Kibana stack or Greylog 2, for example. If you want some commercial tools, you can use a very good tool called Splunk, or if you wanna some cloud-hosted tool, you can use Logly. As well, there are a lot of services which you can use for collecting logs in one place. The next thing is, because if we're gonna have those logs in one place, so how to search them?
Let's think about a case where there was some issue on production, right? And it went through 100 services, or let's say at least 10, whatever. And you would like to see what were the exact requests that were being sent, or some logs that took place during the processing of this business request, the whole one. And here the correlation ID, notion of correlation ID comes. So let's imagine a case that we have a request and there is no correlation ID. So it's a header in HTTP request, let's call it the correlation ID, with some value. So this is the very first request. Let's say a guy wants to take a loan. So this is the first request that comes. It has no correlation ID. It gets the first service. The correlation ID is set to X, right? Some value. And then throughout the whole processing of the business request, it's all the time X. Whether it's synchronous, asynchronous, it's all the time X. And why is it so? Because afterwards, in a very cool tool called Kibana, which is a UI for logs for logs that are aggregated in Elasticsearch, you can see that to the left, you have one correlation ID. This is the very same number. To the right, you can see obfuscated app name. Sorry for our, let's say,
GIMP skills.
GIMP skills, we're not that good. You have 3 different application names: fat web something, fraud service, and a longer fat web something. So actually, it's ordered by time. So you can see that for one processing of a business request, business one, so the one that goes through all the services, you can see how it went exactly, request by request, service by service. And it's easier to debug. Then you can find that I mean, imagine a case where you have a service where you have plenty of multi-threading going on. You actually will have no idea which request or which log relates to this business requirement, business request, if you don't have the correlation ID there. You have to have it to be able to search for stuff.
So next thing are metrics. So the standard setup is Graphite plus some kind of dashboard if you don't like Graphite dashboard as we do. For example, Grafana or Tessera. For system metrics collection, you can use collectd or Munin or something like Cacti. Anything will do. The one thing you have to be able to correlate system metrics with application metrics. It's very easy. It's easier to debug applications sometimes if you have this correlation. For metrics aggregation, you can also use statsd. And many other tools are available online. For example, you can use some hosted solutions, some cloud solutions. There is a lot of stuff on the internet in OSS world. Okay. Oops. Next thing, alerts. So, what about alerts? We should monitor application if, for example, simple checks if application is alive. We should monitor some endpoint, some health endpoint if it's okay, if it's alive. So you can use Nagios, Zabbix, Isinga, or other such kind of tools. For example, if you want to monitor specific metrics in Graphite, you can use Cabot for this. And for logs, also you should monitor your logs. For example, when the exception, when we find exception in logs, we would like to receive an email that on production server, this and this, there was some exception, and this exception is critical. So we would like to know if there is such exception in our logs. So we can configure Logstash to send you an email when some kind of logs appeared in your logs. Okay, so
let's assume that we've passed through the whole way of writing the code, testing it, deploying, building, and we went to production and the world is a safer place. But actually not. I mean, we can do some mistakes, and one of the issues is like code reuse. Actually, the rule, don't repeat yourself, right? It's very cool, it makes sense. But actually not always, because you shouldn't actually always abstract everything. Sometimes what you want to achieve, I mean, you have to be pragmatic. Sometimes, if you copy-paste stuff, you're going to get decoupling, which actually you may want. But what is really crucial to understand is that this is not a solution to all of the problems, right? You shouldn't copy-paste from now on. But what I'm gaining at is that when you're doing microservices, or when you're programming in general, be pragmatic. Sometimes abstractions make no sense. For example, if one of our product owners wanted to be like an architect and define some solution, that he has an idea how to solve stuff. So he wanted to create one abstraction for verification of personal ID numbers. That depending on the country, the verification will take place in a different way. And it does sound nice. But the problem is that there is no common thing over there. I mean, the personal IDs are different. In each country, the way to check them is different. So what he would have to actually do is to send the personal ID, tell this abstraction from which country it is, and then do either if-else for all the countries, but we're not lame. We're going to do a switch, right? Because we're hardcores. But even better, if you have OCJP, you will do a map, because you're not going to do if-else, right? No, it's not the way to go. Sometimes it makes absolutely no sense to go that way. Also, nano-services. Okay, let's read the updates, everything in microservices. Great idea, but who will support it afterwards? You're going to end up with like 10,000 microservices and what? I mean, it's not that easy to live up with 10 microservices or 20, and you want to go down the 10,000 road? It makes no sense. Too many technology stacks. Yeah, I mean, freedom, right? We have microservices, so for ages we've been working with Java 4, with Glassfish and all the stuff, Spring Zero, and now we can go, all the way. I mean, no, pick the right tool, but don't exaggerate. Because, I mean, you can write microservices in brainfuck or whitespace. It's feasible, right? But why should you, right? Afterwards, if somebody did that to you and you have to support it, I mean, I wouldn't want to be the guy who wrote this, right? Because actually it's the good thing about microservices is that they are that small that you can ditch them and rewrite them. Actually, even in our company, some guys created very bad service. I don't know how this happened, even that it's there. But the cool thing is that it's small and you can ditch it and rewrite it, and it's not going to take ages. Management issues. It's also an issue, a very big one, if not the biggest actually, because you have to tell some people who give you the money for what you're doing that, you know what, we have to invest some time and build some foundations, so give us the money and we'll build it, We have to provide infrastructure, hire some DevOps and make them work, even harder on some stuff. And the best thing, Mr. Manager, is that the feature delivery pace will decrease. So can you please give me the money? No, it's very difficult because you have to tell the management that actually you have to do one step back in some things to accelerate afterwards, because otherwise you're going to have a big ball of mud piling up and you'll not be able to progress in the proper way. So that's it from our side. Do you have any questions to us? Yeah, go ahead.
Hi, what about logic which is not triggered by any request, like for instance some schedulers or waiting for some events. How does it fit into microservice architecture?
It's the schedulers are related to some feature, for example. We have the same. For example, we process loan applications, for example. There are some applications and we have to process them. So if you have a bounded context related to loan applications, it's a perfect fit.
Yeah, but I also did some finance software, and very often you have to like cross-cut functionalities that you have to compute loans, deposits, accounts, and I don't know, yeah. And if you created like 3 microservices for each of them, and you have a cross-cut functionality connected with some back office processing, how would you fit it into?
For example, very good question. For example, the same relates to reporting. Yeah. Let's say that we have, that's exactly the same thing. Let's say that you have, who of you knows CQRS as a concept? Okay, so you can separate the reads from the writes. So you can have a separate service specific for reporting. So you have 3 different bounded contexts, but you need one place where you're going to store everything. So you can push some events in the system that, for example, loan applied, loan process, whatever, right? And this reporting service can react to this, and he can, for example, have a relational database which will be exactly prepared for what you just said. The problem is eventual consistency. And now the question arises whether you can accept that or not. Because if not, then we have a problem. But there are possibilities to solve it, etc., etc. But there are ways to solve it. Actually, when we were doing the hackathon, one of the services, a reporting service, say explicitly for that, to show people that you can have 3 services, each using no SQL database, but there can be some reporting team that needs a relational one because they have their tools for that and stuff. And you can live with that, actually. You just listen to events and propagate into the table. It's not easy, but that's feasible.
Thanks.
Any more questions? No more questions. Okay, so thank you a lot. And if you have more questions, you're shy, you can approach us and we can talk. So thanks a lot.
And thank you very much.